This video poster presents a book about Australasian tektites. It contains 42 chapters, as well as a dictionary and a reference list. After watching each video poster, you can download relevant chapters for detailed readings, using the link in the description below. This Muong Nong tektite, from Dalat in Vietnam, was cut to make a thin section, following the white line. The first image shows the top part and locations of impact quartz grains in microcraters, along the cutting line, marked A to E, and the location of an impact quartz grain in an uncut microcrater, is marked Q. The deformation of quartz crystals is dependent on pressure and temperature but also water contents, and their form of alpha quartz or beta quartz. An increase in water contents lowers the PT level, at which quartz crystals can deform, and changes the deformation type from mostly plastic to mostly brittle. Deformation can take place already at temperatures between 400 and 600 degrees Celsius. Probably through the quartz liquid transition interval, between Tg and Tm, quartz is more plastic at higher PT conditions, and more brittle at lower. This is the thin section, and the other side of the Muong Nong tektite. During polishing, all the impact grains were polished off, leaving only the microcraters. Probable sediment cracks with rounded bases are marked with an S. Note, this side of the tektite has sediments attached. The sediments attached contain small quartz grains, comminuted quartz and mini tektites. This sediment was probably attached during the formation, as such an assembly would be unlikely to attach later. During an impact, with winds far above hurricane level, grains would be blown around in large quantities, some hitting and burying the tektite, still in the liquid transition interval. The grains themselves, probably also hot, flattened out during penetration, formed a microcrater, and left a partly cracked and crushed grain. This is the quartz grain remains in the microcrater location A, showing the flattened top surface, the cracks in the grain, and the crushed part below. A drawing to the right shows the details. This is the same grain in location A, seen from a 45-degree angle, from the top, and directly from the top. The top side is melted, perhaps from a following cover of hot comminuted quartz. This is also the impact grain in location A, in inverse colors, showing the impact direction, revealed by the minor impact bodies marked 1 and 2. Impact location B, shows a similar grain, with a flat top, a cracked grain, and quartz crushed at the bottom. To the left a smaller impact is visible. A drawing to the right shows the details. Also the top of these quartz grains are melted, both the large, and the small grain. The grain in location E has had a vertical impact, creating the crater, the cracked grain, and crushed quartz below. Some small engulfed grains remain, here green in the drawing. Also here there is a small impact to the left. The location E grain, in inverse colors, and the top side to the right. To the left is the crater from the thin section, where all the grain, and crushed quartz was polished away. Many Muong Nong tektites contain such impact grains, visible in the surface, and revealed by a microcrater rim. Two more images, from another Muong Nong tektite, with distinct impact crater rims, and impact grains preserved. Muong Nong tektites were not the only rocks impacted by quartz grains in the Muong Nong strewn field. This image is of a melted quartz stone, with an impact quartz grain, containing planar deformation features. Also the quartz stone was impacted by small iron spheres, marked I. Both have a small crater rim around, marked R. Read more about such rocks in later chapters.